So for problem number one here, this is a rectangle. Here, remember the area for a circle is pi times the radius squared. Well, in this problem, we're given the diameter, so we need to find that radius, which will be half the diameter, which will be 4 feet. So this will be pi times 4 squared, 50.24 square feet. Now remember that 50.24, I'm using pi as 3.14 instead of the pi button. If you use the pi button, you might get 50.26, 50.27. Either one of those is acceptable. For number three, a triangle. Remember the area for a triangle is the length times the width of that related rectangle divided by 2. Or you can think of as base times height divided by 2. So here we'll think of this 6 times 27. And of course divided by 2. That gives us 81 squared. Our next one over here, last one is a trapezoid. Trapezoid, remember, has two bases. The bases are the sides that are parallel. So in this case, that is the 6 and the 20. The area is the average of the bases. So we add them together and divide by 2, and then multiply by the height. So here that area will be 6 and then divided by 2. And then times our height of 15. So 6 plus 20 is 26. 26 divided by 2 is 13. We can get rid of the parentheses there. 13 times 15 is, what is that, 195 square inches. So we can find the area of those four basic shapes. And as we saw yesterday, they are all found based off of the rectangle. Now, we also talked briefly yesterday about some conversions. I'm going to have you try these in your notes as well, see if you can remember. We're going to convert 48 inches into feet.
Recording is on.
4 square feet into inches. Let's do 81 square feet into square yards, and we'll do one more. 4,500 square centimeters to square meters. I'll give you a minute to do those, and then we'll go over those. So for the first one, 48 inches. We put that over 1. We're going to have inches on bottom, feet on top. 1 foot is 12 inches. So the inches cancel out. We have 48 feet over 12. 48 divided by 12 is 4 feet. Now that's the only one up here that was just plain inches and feet. All the other ones, you'll notice, are square feet, square inches. So this one here, 4 square feet, if I put that over 1, I'll put square feet on bottom over here, square inches. 1 square foot, it's not 12 square inches, it is 144 square inches. So the square feet cancel. 4 times 144 is 576 square inches. 1 times 1 is 1. So this is 576 square inches. The third one there, 81 square feet. Put that over 1. Going into square yards, we'll put square feet on bottom, square yards on top. 1 square yard is 9 square feet. Remember, 1 yard is 3 feet, so a square yard is 3 by 3 or 9 square feet. Square feet cancel out. 81 times 1 square yard is 81 square yards. 1 times 9 is 9. That divides out to be 9 square yards. For the metric conversions, remember each spot on the chart is multiplying or dividing by 10 for lengths. When we go to areas, each spot on the chart is multiplying or dividing by 100. So for areas, each spot on the chart is 2 decimal places. So on the chart, centimeters to meters is 2 spots to the left. Since it's centimeters squared to meters squared, those 2 spots become 4 spots, 4 decimal places. So decimal point starts there, we go 1, 2, 3, 4. That's 0.45 meters squared. Any questions on those? Any questions off the homework from yesterday? Okay, I think pretty much all of you have it turned in, the quiz that from yesterday. There's also a new quiz today. It's labeled Quiz 10-1. That'll be due by noon tomorrow, by noon September 23rd. That's out there in Blackboard for you as well. Okay, so for today, I want to build on those first few problems we did here, the areas. And what happens when it's not just a straightforward shape like a rectangle, triangle, trapezoid, or circle. Something like this would be about the simplest example we can run into. So let's say we have 32 feet across here. Go 24 feet here. Let's call this 20 feet, and up here we'll call this, well, let's call it 22 feet. If I ask you to find the area of this, there are 2 different strategies you could use. Method 1 is to cut it apart and then add the pieces back together. What does that mean? Well, that means I could either cut it across here and have 1, 2 rectangles, or I can cut it this way and have 1, 2 rectangles. Since I have it drawn in that way, let's leave it like that for now. So the first rectangle is 24 by 22.
Recording is on.
Times 22 feet. 24 times 22 is 528 square feet. Number 2, that's 20 feet. We need to know this length up here. What's that length going to be there? 32 minus 22 leaves us with 10 feet there. So that'll be 20 feet times 10 feet. Equals 200 square feet for that section. Those add up to 728 square feet for our total area. Well, our second method, method 2, is to fill in missing pieces and then subtract them out. Let me show you what I mean. Well, for that, we might do this. We'd fill in this corner and find the area of that big rectangle. Well, that big rectangle is 24 feet by 32 feet. We're going to get 768 square feet. But now we have this extra rectangle up here that we need to take back out. That's not really there. That's 10 feet in this direction. What's our dimension here in this direction? Vertical, so we can only use other vertical dimensions. We have 24 and 20, so that one has to be 4 feet to make up the difference. So that piece that we have to cut out is 4 feet by 10 feet, or 40 square feet. Cut that out, we subtract it, in other words. We're left with 728 square feet of area. We get the same answer either way. And in this problem, it's about the same amount of work either way. It really doesn't matter which method you use. There are other problems that may be a little bit easier to do one way or another. All those lines there are square corners, all the right angles, even though they may not all look like it. Let's make this 8 inches, 8 inches, 14 inches, 10 inches. We'll make this 20 inches, 24 inches. This one's about the same amount of work either way. It might be a little easier to fill it in and subtract out, but let's do it both ways. Let's do it by cutting into pieces. Now, if I'm going to cut this into pieces, probably easiest to cut it like that. I have 1, 2, 3 rectangular pieces. That first piece is 24 by 10. 24 inches times 10 inches, 240 square inches. My second piece is going to take some work. What's that dimension right there going to be? Yeah, 24 and 8, that has to be
16.
16, thank you. So piece 2 is 16 inches by 14 inches, which is what, 224 square inches, I believe. It is. And then piece 3 is 20 by, we know this down here still has to be 24 inches because this is 8 inches here and there, so it has to go back 16 inches plus 8 has to be 24 again. So piece 3 is 24 inches by 20 inches, or I forgot a 0 on this first one. It'd be 240. This would be 480 square inches. So that adds up to what, 4, 14, 944 square inches of total area. However, this is one that I think might be slightly easier if we did the big rectangle here first. You just subtract out the missing piece. Of course, we do have to know this length here. It'll be 10 plus 14 plus 20 is 44 feet, or 44 inches, I should say. So that big area is 44 inches times 24 inches, which is, what is that, 1,056? A little off there. 1,056, this is correct. Square inches. And then we subtract back out this piece here that's missing, which is 14 by 8. Which, what is that? 84, 104? Or 114? 112, there we go. Square inches. We subtract that, and we get 944 square inches, just like we had before. So on many of these, it'll be flat out up to you which method you think is going to be the simplest and which method you think is going to work best for you. Some of them, like I said, one method or another is definitely going to be easier. This example might be one of those. So let's do 6 inches, 8 inches, 12 inches, 14 inches, and 3 inches, and 18 inches here. For this one, trying to find the bigger piece and subtracting back out is going to be a little tedious because stuff don't line up. It's not just a simple rectangle that's missing. So this one probably is easier to cut it into smaller pieces and add those pieces back up. Now I always try to cut by just cutting in a single direction. I know some people, they got lines cutting all over the place like that, cutting them up. To me, that just clouds it, muddies the water. I try to find a direction where I can just make all my cuts horizontal or all my cuts vertical and make it work that way. It just seems simpler to me to do that. So anyway, we're going to add up piece 1 here is just 14 by 3. So 14 inches times 3 inches is, what is that, 42 square inches. Piece 2. We have 8 inches here, but we need to know this dimension. Well, what is that dimension going to be across there? We've got the 14 and we've got the 6, so that has to be 8 inches. So piece 2 is 8 inches by 8 inches. 64 inches squared. And piece 3, if this is 8 inches, that means all the way across here is 20 inches. So this is 20 inches by 18. That is 360 inches squared. We add all those up, we get 466 square inches as our area. So that one I think is definitely easier to cut it into smaller rectangles and add them up. Trying to do a big rectangle, then figuring out what's the area of this missing part would be kind of confusing. Now, on the other hand, there are problems like this next one. We'll make it work. Let's say this is 2 inches, 10 inches, 36 inches there, 28 inches. Call this 4 inches. Call this 10 inches again. And let's see, we got 32 left. Let's call this 22 inches. And we need to know this piece down here. oh, let's call this 22 inches. To find the area of this one, if I were trying to cut this into pieces, it would get ugly. I mean, I can't just, I suppose I could cut like this and have 4 pieces, but that's not very neat and pretty. This is one that would probably be way easier, at least to me, to fill in the missing pieces than subtract them back out. We have, of course, we need to know this overall length, which is 36 plus 2, that's 38 inches. And this overall length, 28 plus 10 makes it 38 inches. So that overall area is 38 inches by 38 inches. Or 1,444 square inches. Now we have 3 pieces to subtract out. This one is 4 by 10. It's 40 square inches. This one here is 2 by 10. 2 inches by 10 inches. 20 square inches. This one we need some dimensions. We know it's 38 all the way across. This is 10 to here, plus another 22 makes this 32. This has to be 6 inches to get up to 38. Same going this way. This is 38 all the way down. We have 4 here. 22 makes this 26 inches to there. We need another 12 inches here to add up to the 38. So that piece is 6 inches by 12 inches. 72 inches squared. So that adds up to a total of 132 square inches that needs to be subtracted out. So we subtract that out. Get 1,312 square inches of total area. Well, we've talked about circles. Now let's talk about pieces of a circle. We already looked at a half circle in our quiz that was due. As far as the perimeter of a half circle, let's look at the area of a half circle. If I tell you that this is 10 inches across here, and I want to find that area, we know that if it were a full circle, the area would be pi times radius squared. So we would need to know the radius. The diameter is 10. The radius would be 5 inches. So the area of that whole circle would be pi times 5 squared. But we don't have a whole circle. We only have half a circle. So we divide that by 2. Pi times 5 squared is 78.5. Divided by 2 is 39.25 square inches. Or we could have a quarter circle. That box tells us that's a right angle, which tells us that's 1/4 of a circle. If I know that this here is 4 inches, the area, if that were a full circle, would be pi times 4 squared, because 4 would be the radius, but it's not a full circle, it's a quarter of a circle. So we divide by 4. That gives me 12.56 inches squared. Now for right now, we're going to stick with simple fractions of a circle. Half a circle, quarter of a circle. At some point, we will come back and look at what we call sectors of a circle, where we can find right down to the exact degree how big a section of a circle is. For now, we're not going to get quite that fancy. But when we throw in pieces of a circle, it affects the way we find areas, or might affect the method we use to find areas. So here we have a rectangle with a half circle on the end of it. If I tell you that this here is 20 feet, and this here is 20, oh, let's go 24 feet. First of all, circles are a great way, one of the few ways we have of transferring dimensions from vertical to horizontal. Let me show you, this is a great example of that. We know that the distance from here out to there has to be the difference between the 20 and the 24. That has to be 4 feet. Well, that's the radius of our circle. And the radius of the circle is the same in any direction. This is 4 feet, that is 4 feet, that is 4 feet. Well, that's 4 feet, and of course this is also a radius, that's also 4 feet. That tells us that the width of our rectangle is 4 plus 4, or 8 feet. So these pieces of a circle are one of the few ways that we can transfer dimensions from horizontal to vertical or vertical to horizontal. So now we know that we have a rectangle here. I'm going to call piece 1. That's 8 feet by 20 feet, or 160 square feet. And our second piece here, piece 2, is half a circle with a radius of 4. That's pi times 4 squared divided by 2, otherwise known as 25.12 square feet. So we add those pieces, we get 185.12 square feet for the area of that figure. So there's a case where we had no choice. We had to cut it into smaller shapes and add it together because of the presence of the circle. Well, this next shape is going to look awfully familiar. Pretend that looks like a half circle. This is 20 feet and this is 8 feet. Try again on that drawing. A little closer. Yeah, a little bit better maybe. So this is a rectangle with a half circle cut out of the end of it. This was a rectangle of the same size, 8 by 20, with a half circle added on to the end of it. So here we have no choice. We're going to start out by finding the area of the big rectangle. That's going to be 20 feet times 8 feet, or 160 square feet. And then we have this half circle that's missing. Well, because this is 8 feet, we know that this is also 8 feet. Which means our radius is half of that, or 4 feet. So that's pi times 4 squared. That would be a full circle. We have half a circle. So pi times 4 squared divided by 2 is going to be 25.12 square feet. But now it's being subtracted because it's cut out. So this is 134.88 square feet of area for that shape. Any questions there? So as we've seen, these portions of a circle are a great way to transfer dimensions from horizontal to vertical. So if I look at this piece here, again, that's a quarter circle there. If this is 20 inches and this down here will go 16 inches, if I tell you that this side is 10 inches, what's this side here have to be? Well, we know all the way across here is 16 inches. So 10 plus that piece would have to be 6 inches to make that equal out. But that 6 inches is the radius of a circle. So that's 6 inches here, 6 inches here. More importantly, it's 6 inches here. So if that piece is 6 inches and this whole side was 20, 20 minus 6, this piece has to be 14 inches. Well, like we said, that circle is one way to transfer dimensions from the horizontal scroll to the vertical direction. Let's jump ahead a couple of weeks. In a couple of weeks, we're going to talk a lot about surface area. For right now, we're going to talk about the surface area of a cylinder. Right, I'm not totally sure, but we'll live with it. So pretend that looks like a cylinder. Let's cut across here. Let's make that 10 feet across there. And we'll make this 20 feet across up here. Surface area is the area of just all the surfaces. Well, we have two circles here, the bases of this, here and here. Well, to find the area of that circle, we need the radius. The diameter is 10. The radius here will be 5 feet. So the area of that circle is pi times 5 feet squared, which is 78.5 square feet. Now this one is also 78.5 square feet. So we'll put that in. There's two of them. They're identical. So now all we need is the area of this part that is connecting the two circles. It's wrapping around, if you want to call it that. It's referred to as lateral area. We'll talk about that a lot more again in a couple of weeks when we talk specifically about surface areas on all sorts of shapes. But for right now, let's say this is our cylinder. Pretend those are round on the ends. It's just a piece of paper that's rolled up. The height of this cylinder is the 20 feet, and the diameter of this circle on the end is the 10 feet. Well, if I want to know the area of this part, I can just slice it down the side and unroll it. And this rectangle that I have, this height is still the 20 feet of the circle. The length of this is the distance around the base of that cylinder, the distance around that circle at the base. So that rectangle is 20 feet tall. This dimension is just going to be pi times diameter. Diameter of that circle is 10 feet. This is 31.4 feet of length. So that lateral area is 31.4 feet times 20 feet, or 628 square feet. Now we add that up. This is what, 157 plus 628 is 779 square feet is my total surface area. So we can break things down piece by piece like that to find surface areas or other areas if we want to. So for right now, your homework is in your little book. Units 24 and 25, the odd-numbered problems. Don't forget there's a quiz out there due for tomorrow. I believe it's labeled Quiz 10-1. Sorry about giving you quizzes 2 days in a row, but the 2-hour class on Monday often works out to that. Okay, so that is everything for today.